Hello everyone. So in our previous video we saw a problem, squares of a sorted array. We saw the animation of the algorithm step by step. So in this video we'll actually code the algorithm and we'll test its working in the main method. So before we start, in case if you're new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So here in our arrayUtil class, I will be creating one method as public static. We'll give a name to this method as sorted squares. So this method will take in an array, and what this method will do is it will do the square of each and every element of the array, and whatever the array it will return, that array will also be sorted. And this array is already sorted. So in our animation video we saw that we can solve this problem using two pointer technique. So here first we will create an integer variable n. This will store the length of the array. Then we will create one pointer I, which will start from the 0 index, and one pointer j, which will start from the last index. So the last index will point to array.length -1. Now as we want to return a sorted array, so we'll create a result array. The size will be the same as our input array. Now here what we will do is we'll provide a for loop, and inside that for loop we will try to fill this result array from the end. So here we will start from k equals to n-1, because n-1 is the last index, and it will go to when k is greater than or equal to 0, k minus minus. So from kn-1 it will go to 0, and with each iteration it will get decrement by one position. So friends, here you can see that this array is actually sorted array. So if I take this example, so here you can see that this array can contain negative values. So if the array contained only positive values, this problem would have been very easy. We would have just done the square of each and every number and simply place it into the result array at their respective indexes. But as this array contains the negative elements also, so here for example, let's say it was given something like this. So we can't directly do the square of each and every number and put it into the respective position, because this will result something like this. -4 into -4 will give 16. -1 into -1 will give 1. 0 into 0 will give 0. And 3 into 3 will give 9. So here you can see we can't directly just square the numbers and put it into the respective position, because this array is not sorted and we want to return the sorted array. So one thing is we just square and at the end we just do the sorting explicitly and return. But that would be a very bad algorithm time complexity wise, because we are actually using the sorting technique. So in this algorithm, using this for loop, we will try to sort this array properly so that it would look something like this, that 0 should come here, then 1, then 9, and then 16. So usually in order to do that, what we can do is we try to compare the absolute extreme values. So whichever value is greater, we do their square and we simply put it into the last index. And similarly we go on doing like this. So for example, if we do the absolute value of -4, we'll get 4. And we see that 4 is greater than 3. So it means if we do 4 into 4 or -4 into -4, we'll get 16, and we can safely place 16 at the end. And after filling this position, we just come to this position, and after using this -4, we just shift here. So in the next iteration, we simply compare the absolute value of -1, which will give us 1, and we'll compare 1 with 3, and we see that 3 is greater than 1. So we simply do 3 square and we put 9 at this position, and similarly we keep on doing like this. So here the main idea is to take the absolute values of the extreme values, try to compare them, and whichever is the greater, do their square and put it into the result array at the index which is starting from the last index, which is n-1. So here we provide a condition as if math.absolute of array of I. So we have created these two pointers. One would be at the start and other would be at the end. If it is greater than math.absolute array of j, so what we can do is, if the absolute value at ith index is greater than absolute value of jth index, then in our result at kth index we will assign array of I into array of I. So we are doing the square of this number and we are assigning it to the result array. After doing that, we know that we have used, for example, we have used this position of the I. So we simply increment I, because we need to now take another value, because we are done with this value. Let's say for example, and else, then we can simply assign array of j into array of j. And as we are assigning array of j and it is basically starting from the last index, so it signifies that we have used this value, for example, and now we need to go one step before to it. So what we do is we do j minus minus, and after the first iteration of for loop in our result array, let's suppose if we take this example, 16 got occupied at this place. So we are doing k minus minus because now we need to fill this position. We have filled this position, now we need to fill this, and with each iteration we will fill one position, and at the end we'll simply return the result. So friend, this is the algorithm. Now we will test its working in the main method. So here I will be using this array which we discussed in our slide as well. Here we will get the result array. We will call sorted squares. We pass in the array, and at the end we'll simply print the array. And if I run the main method, so here you can see that we got the answer at 0, 1, 9, 16, 100. So this 0 came from this 0, this 1 came from -1, 9 came from 3, 16 came from -4, and 100 came from 10. And how it came? We simply squared them, and using this for loop we actually placed them at their respective position so that the final array is also sorted. So friends, I hope you must have liked this video. In case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day.